let's look at problem B. We already found the perimeter and area of each triangle. And with my help, we kind of used a formula that I used when I was your age. So look at triangles A through F again. Use grid lines, draw the smallest possible rectangle around each triangle. We want to find the area of each rectangle. Record your data in the data table for question A, part 2, and compare the area of the rectangle to the area of the triangle. Compare a pattern that tells you how the two are related. We're going to use this lab sheet or these triangles that were pre-made. So we're going to find the area of each rectangle. So first, it wants us to use grid lines to draw the smallest possible rectangle around each area. And then we're going to find the area of that rectangle and compare the data. So let's start there. So the smallest rectangle around A is right here. Area formula is area equals length times width. The width equals 1, 2, 3, 4, 5, 6. So the width equals 6 centimeters. Now the length, which is left to right, we have 1, 2, 3, 4, 5. So this is 5 centimeters, and that's the length. So the area is length times width. So the area is 5 times 6. And area equals 30 centimeters squared. Now let's look at the area for B. It doesn't want us to find perimeter, just the area. Okay, so the smallest rectangle around is like that. And the width is 1, 2, 3, 4, 5, 6, 7. 7 centimeters, and that's the width. And the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 centimeters. So the area equals length times width. Area equals 10 times 7. Area equals 70 centimeters squared. The smallest rectangle around triangle C is going to be from here to here. The width is 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters, and the length is 3 centimeters. So the area equals length times width. Area equals 3 times 8. Area equals 24 centimeters squared. Let's find the area for the smallest rectangle around D. So this is a little bit of an awkward rectangle, and that rectangle is actually creates 2 triangles around. So I'm going to go from this vertex to the top line here, and then I'm going to go around this way, and there's the smallest rectangle around. The width, 1, 2, 3, 4, 5, 6. 6 centimeters in width, and the length is 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters. So the area is length times width, or 6 times 9. Area equals 54 centimeters squared. So E went like this. We have the base, the height, and the rectangle is going to go around to create 2 triangles. So I'm going to go here and then across, and I'm just going to overlap here, triangle C. So there's the rectangle, the smallest rectangle around triangle E. The width is 1, 2, 3, 4, 5, 6, 7 centimeters, and the length is 1, 2, 3, 4, 5, 6 centimeters. So area equals length times width, which means that area equals 6 times 7, which equals 42 centimeters squared. So I'm going to look at the last one finally, triangle F, and triangle F has a base that is this way. It's kind of upside down, and I'm going to draw a rectangle around. So the smallest rectangle is from this corner across to this corner. The width is 1, 2, 3, 4, 5, 6, 7, 8 centimeters. And the length is 1, 2, 3, 4, 5, 6 centimeters. And if we plug in the formula, area equals length times width. Area equals 6 times 8. I'm going to move this down. Area equals 48 centimeters squared. All right, so look at B1 above the paper, right above here. It says to find the area of each rectangle you drew, record your data in a data table with the areas of the triangles from part A, question A, part 2. And then we're going to compare the area of the rectangle to the area of the triangle, describe the pattern that tells you how to record all of the information. The areas of rectangles. Rectangle A is 30 centimeters square for triangle A. Triangle B is 70 centimeters square. And that's the rectangle. I'm going to go back to my triangles. The area of triangle A is 15 centimeters squared. Okay, so we're going to compare the area of these between triangle and rectangle. Describe a pattern that tells you how the area of a triangle and a rectangle are related. I can already see that the area of a triangle is half of the area of the rectangle, right? Because this is area equals 1/2 of the base times the height, which is also the length, the width and length of a triangle, of a rectangle. And this is area equals length times width. So if I go back to these models, if I were to illustrate how they're similar, is that this is the area of a rectangle and this is the area of a triangle. It's half of the rectangle's area. The triangle in a rectangle is half of the area of the entire rectangle. This triangle is half of the area of this entire rectangle. The area of a rectangle is twice the area of one of its triangles. Okay, I'm going to respond to problem B2 and problem C1. So B2 says to compare the area of the rectangle to the area of a triangle. Describe a pattern that tells you how the two are related. I used this data to come up with a response. A rectangle is twice the area of its internal triangle if cut in half. So 35 is half of 70, 12 is half of 24, 27 is half of 54, 21 is half of 42, and 24 is half of 48. So in conclusion, after I looked at triangles A through F, I compared the area of the rectangle to the area of a triangle. The area of a rectangle and the area of a triangle inside of that rectangle is half the area of the rectangle. For example, triangle A's area is 15 centimeters squared, but the rectangle around triangle A is 30 centimeters squared, 2 times the area of 15 centimeters. We can respond to this any way. Everyone will have a different way of responding to it, but that's how I kind of responded to it, but I know that there's places where I can be more precise, but this is a draft. Now for problem C1, use your results from question B to write a formula to find the area of any triangle. Explain why your formula works. Now this formula I gave you because we're really not in the classroom to have an in-depth discussion about how to find area. So I'm just giving you the formula that I grew up with. And that formula is A equals half of the base times height. So if you always say half of, that means you cut in half of whatever is in this parentheses. So half of this product, half of 12, half of 24, half of 10, It's just easier to solve what half is if you say half of instead of 1/2 times base times height. So the reason why this formula works for me is that the formula works because it's exactly half of a rectangle's length and width. And that's the rectangle around the triangle. So I could have been more precise on this one too. I could have added half of the rectangle around the triangle. So for these two, I could have edited some more to be more precise. So this is just a draft.